Imagine you are floating. Not in a pool. Not in a dream. You are floating 370,000 kilometers from the only home humanity has ever known, and the Earth behind you is no longer a world. It is a whisper. A pale blue suggestion against an ocean of black so deep, so absolute, that your mind refuses to accept it. Ahead of you, filling the porthole window from edge to edge, is the moon. Not the moon you know from postcards and childhood nights. This one is violent and ancient. A landscape of craters and silence that has not changed in a billion years. You are close enough to see individual mountains. Close enough to feel like you could reach out and drag your fingernail across its surface. And then, a voice crackles through your headset from 370,000 kilometers away. Artemis II, you have just broken the record. In that moment, you are the farthest any human being has ever intentionally traveled from Earth. Farther than any Apollo crew. Farther than any space station. Farther than anything carrying a human heartbeat has ever gone, and returned. But to understand why this moment matters, you first need to understand the moment it surpassed. April 14, 1970. Apollo 13 was supposed to be the third moon landing. Then, 56 hours into the mission, an oxygen tank in the service module exploded. 3 astronauts, Jim Lovell, Fred Hayes, and Jack Swigert, were suddenly hurtling toward the moon in a crippled spacecraft with no power, no heat, and no guarantee of ever coming home. To save fuel and use the moon's gravity to slingshot them back to Earth, Mission Control plotted a desperate free return trajectory that swung them around the far side of the moon. In that desperate arc, Apollo 13 reached 400,171 kilometers from Earth. A record set not by triumph, but by catastrophe. Not by ambition, but by survival. For 55 years, no human being ever went farther. Until now. Here is the number that most people say without ever truly feeling it. 370,000 kilometers. If you drove a car at highway speed, non-stop, no traffic, no sleep, it would take you over 154 days to cover that distance. If you stacked every human being who has ever lived shoulder to shoulder, you still would not reach the moon. And at the speed of light, the fastest anything in the universe can travel, a radio signal from Artemis II still takes 1.2 seconds each way to reach Mission Control. At that distance there is no instant advice. No quick rescue. No comfort of a fast answer. Every decision the crew made lived in that 2.4-second silence. But here is the problem with describing this distance in numbers alone. Numbers don't scare you. What scares you is what that distance actually means for the human body. Because space at lunar distance is not just empty. It is actively trying to kill you. On Earth, you are protected by something you cannot see and rarely think about, a vast magnetic bubble called the magnetosphere. It deflects billions of high-energy particles every second, particles fired across the galaxy by dying stars, supernovas, and the raw fury of the sun itself. The moment Artemis II left low Earth orbit, that protection disappeared. Out in cislunar space, the crew was exposed to galactic cosmic rays, subatomic particles accelerated to 99.9% the speed of light, capable of passing through the Orion capsule's walls as if they were tissue paper. Through the seats, through the suits, through the astronauts themselves. And here is something that stops physicists cold. Astronauts in deep space report seeing flashes of light with their eyes completely closed, in total darkness inside a sealed capsule. Those flashes are cosmic ray particles passing directly through their retinas and triggering their visual neurons. Think about that. The universe is so energetic out there that it can make you see things through closed eyelids. Artemis II's radiation monitors logged elevated readings within hours of leaving Earth's protective shadow. The cumulative dose on a 10-day cislunar mission can exceed what an ISS astronaut receives in an entire 6-month career. But that's not the worst part. The worst part is that radiation is the danger they planned for. It was the danger they could measure, monitor, and partially shield against. The danger they could not fully control was already baked into the mission design itself. To reach maximum distance and return safely without burning excessive fuel, Artemis II used the same gravitational principle that saved Apollo 13, a free return trajectory. The concept sounds elegant. Simple even. You approach the moon at a precise angle, let its gravity curve your path around the far side, and the moon itself flings you back toward Earth. No complex orbital insertion. No high-stakes engine burn near the surface. The moon does the work. But elegant and forgiving are not the same thing. The trajectory is calculated to within fractions of a meter per second. A deviation of just 1 meter per second during the critical engine burn, the equivalent of a gentle walking pace, puts the capsule on an entirely different path. A path that might not lead back to Earth. And at 370,000 kilometers, Mission Control's response to any emergency arrives 1.2 seconds after it was sent. That gap, that 2.4-second round trip, is not an inconvenience. It is a chasm. Every abort decision, every system failure response, every life or death call lives in that silence. The crew were not just far from Earth. They were, in every practical sense, alone. And this is where things become truly unsettling, because the mission's most dangerous moment wasn't out there, near the moon. It was coming home. Returning from lunar distance is not like re-entering from the International Space Station. The physics are categorically different. At ISS altitude, the capsule re-enters the atmosphere at roughly 7.7 kilometers per second. Manageable. Survivable. Tested hundreds of times. Returning from the moon? Artemis II hit Earth's atmosphere at nearly 11 kilometers per second, almost 40,000 kilometers per hour. At that velocity, the heat shield faces temperatures exceeding 2,760 degrees Celsius. To give that number context, that is hotter than the visible surface of the Sun. Before Artemis I, the uncrewed test flight in 2022, engineers were confident in the heat shield. Artemis I flew further than any spacecraft designed for human spaceflight, reaching 430,000 kilometers. It performed brilliantly. But when engineers analyzed the heat shield after recovery, they found something they had not predicted. Unexpected erosion patterns, charred sections where the ablative material had burned away differently than the models suggested. They did not cancel Artemis II. They did not fully resolve the question either. They assessed the risk. They reran the simulations. They adjusted what they could, and they put 4 human beings inside that capsule anyway. Because that is what exploration has always required. 4 people crossed this threshold. Commander Reed Wiseman, a U.S. Navy test pilot and veteran ISS commander. Mission Specialist Victor Glover, the first black astronaut to travel beyond low Earth orbit. Mission Specialist Christina Koch, the first woman to go. And Canadian astronaut Jeremy Hansen, the first non-American to reach lunar distance. In 10 days, these 4 people traveled farther than any human being has ever gone on purpose. They flew a trajectory last traced, unintentionally, by 3 men who were trying desperately not to die. And they brought back something more valuable than moon rocks. They brought back data. Every heartbeat logged. Every radiation reading recorded. Every system performance measured against the models. Because the real purpose of Artemis II was never the destination. It was the proof of concept. The answer to the question, can we actually do this? And the answer for the first time since 1972 was yes. Here is a number that should stop you cold. In all of human history, across 300,000 years of Homo sapiens walking this planet, exactly 27 people have ever left low Earth orbit. 27. Every revolution, every war, every empire, every technological leap, every century of art and science and suffering and love. And at the end of all of it, the species managed to send 27 individuals beyond the boundary of Earth's gravitational cradle. Artemis II's crew brought that number to 31. The window in which this is even possible, the technological, economic, and political alignment required to sustain a human deep space program, is extraordinarily narrow. We came within one political cycle of canceling the entire Artemis program multiple times. The funding arguments never fully stopped. We have been to the edge of this kind of exploration before. We walked on the moon 12 times between 1969 and 1972. Then, for reasons that were entirely human, budget, politics, shifting priorities, we simply stopped. And we did not go back for more than half a century. The universe did not notice. The moon did not change. Only we did. Imagine you are floating again. The same window. The same Earth. But now you know what it cost to be here, the 55 years of waiting, the physics that had to be relearned, the heat shield that held, the 4 people who trusted the math and climbed inside. Every astronaut who has ever seen Earth from this distance reports the same thing. The borders disappear. The arguments disappear. The wars and the ideologies and the noise, all of it reduces to one image. A blue circle. Alone. Fragile. Beautiful in a way that has no adequate word in any language. The moon has been here for 4.5 billion years. It was old before the first fish swam in Earth's oceans. It will still be here long after every trace of human civilization has been erased by time and entropy. But the window in which a species could look up at it, build machines capable of reaching it, and choose to send people there, that window is not guaranteed. It is not permanent. It is not written into the laws of physics that intelligence survives long enough to explore. 410 days for human beings went farther than any before them. They were alone at the edge of everything familiar. and then they came home. That choice, to go and to return and to come back with knowledge instead of just glory, may be the most quietly profound thing our species has ever done. Because the universe does not keep its most beautiful things forever. And neither do we. But sometimes, just sometimes, we reach for them anyway. If this journey moved you, subscribe. Because Artemis 3 is coming. And next time, the view will be from the surface of the moon.